Dear viewers of Akshi.com, by Vetti from Pondicherry. So next, I am going to discuss the most important chapter, periodic table. Dear students, we know there are totally 118 elements are known so far. Totally 118 elements are known. 118 elements are known. And these elements, actually 92 occur in nature. The remaining elements, actually they are artificially prepared, man-made. So these 92 elements we can classify by two ways. One is based on the state, solid state, liquid state and gaseous state we can classify. The same way we can classify based on the properties, metals, non-metals and metalloids we can classify. Now the important thing is when you want to study chemical bonding, reactivity, preparation, properties, everything, so we have to remember these properties in a systematic way for all the elements. So how to remember it? Is it any method? So first the scientists, they want to the group elements based on the properties. So based on the physical and chemical properties, if they are identical, they want to group together. So this grouping they are called as periodic table. Okay. Now coming for the what are the types of periodic table that is starting from the history. Let me discuss one by one. Initially, when elements were started are known. So the first man, he called it Brown hypothesis. He proposed very simple the hypothesis given. That is, all elements are, that is given as simply nothing but protons. All elements made up of protons. Very simple definition is given for that Brown hypothesis. So here, the next is law of triads. It was introduced in John Dobrynin 1829. Law of octaves was introduced by John Newland in 1865. Lothar Meyer arrangement was given in 1869. Mendel's periodic table was given in 1869. Modern periodic table was given by Moseley in 1913. And long form of periodic table was given after 1913. That's what we are following. So let me go one by one to discuss, then you can understand. So what you are saying is Brout, he proposed Brout hypothesis. Very, very simple. I have already indicated. All atoms are made up of proton. Very, very simple. But it's only in historical importance. We are not having any use in this, so I will not waste time in this. Let me go for the next one. So what you are saying is Dobrynin. So he proposed law of triads. What is law of triads? Just see. This is the most important. That is, the atomic weight of these central elements of the triad means 3, is approximately equal to arithmetic mean of the other 2. This is the most important group of elements. So according to him, so he grouped 3 elements together, 3 elements together, 3 elements together, and all the 3 elements having a characteristic atomic mass. And he pointed out, if you take the central atom, then the atomic mass of the central atom will be the arithmetic mean of the first and third. This is called the law of triads. Specifically, let me give 1 or 2 examples. I will explain. Now you take lithium, sodium and potassium. 3 he grouped together. We know lithium, sodium and potassium nowadays we know it is called nothing but alkali metals. So these metals grouped together. So why he grouped? So if you take atomic mass of lithium is 7, sodium is 23, potassium is 39. Okay. Now if you take lithium 7 atomic mass, potassium 39 atomic mass, simply add now 7 plus 39, total will be 46. Divided by 2, you will get the 23. So that is the 23 atomic. So this is the arithmetic mean. So 23 the atomic mass of sodium. So it is 100% successful in this lithium, sodium and potassium. He succeeded. That means, let me repeat again, the atomic weight of the central element here sodium of the triad lithium, sodium, potassium is approximately equal to arithmetic mean approximately, but in this case accurately equal to arithmetic mean of the other two. Here arithmetic means 7 plus 39 by 2, nothing but 23. This is 100%. Suppose you go for another example. You go for calcium, strontium, barium. Calcium again he grouped with these three elements to group together. Calcium atomic mass 40. Strontium, that is actually he is going to identify, that is 87.5, and this is 137 is the barium. So you take now calcium and from barium, if you add total 137 plus 40, then divide by 2, that value comes 88.2. It is approximately equal to 87.5. So this is law obeys, law of triad obeys. Approximately equal to arithmetic mean. So it is almost equal to 87.5. Again, calcium and strontium, barium obeys law of triads. The third group, chlorine, bromine, iodine. You take example. Atomic mass of chlorine is 35.5, bromine 80, and iodine 127. So if you take arithmetic mean, you add 35.5 plus 127, divide by 2, you will get 81.25 is the answer. Arithmetic mean, AM, arithmetic mean. It is very close to 80, the atomic mass of bromine. That is, so chlorine and iodine and bromine grouped together. So if you add the atomic mass of chlorine plus atomic mass iodine, and then if you divide by 2, that will be the arithmetic mean of bromine, that is nothing but 81.25. Again, law of triad. So chlorine, bromine, iodine obeys law of triads. The same way, I can go for sulfur, selenium and tellurium. Sulfur, selenium and tellurium. So sulfur 32 atomic mass, selenium 79 atomic mass, tellurium 128. So arithmetic mean is 80, which is very close to the accurate mass 79. So approximately equal. Again, this group also obeys law of triads. The last one. Carbon, nitrogen and oxygen. This group again. So carbon atomic mass 12 and nitrogen atomic mass 14, whereas oxygen atomic mass 16. So arithmetic mean of 12 plus 16 divided by 2, nothing but 14, is accurately coincides. So this is the most important law of triads. The atomic weight of the central element of the triad is approximately equal to arithmetic mean of the other two. So normally what type of question will be asked in the competitively? One among the following group of elements obey law of triads or will not obey law of triad. This question will be asked. So for that purpose this is useful. Okay, let me go for the next one. That is law of octaves proposed by John Newland, that's what you are seeing. Let me go for the next. What is law of octaves? So when the elements are known at this time, automatically you have seen already, that is John Newland. He grouped all the elements in a group of 8 elements. In a group of 8. The first one is a group of 3. Now this John Newland grouped the elements of 8 elements. So that's why it's called the law of octaves. So when the elements are arranged in the increasing order of atomic mass, the properties of 8th element repeated like that is 8th note in an octave of music. This is the most important comparison. Let me repeat again. The properties of 8th element repeated like 8th note in an octave of music. So let me explain here. Here 1 or 2, then you can understand. What way 8th element will repeat the other one? We'll come back. Just see here. Suppose let me start with lithium. Lithium is 1, beryllium is 2, boron 3, carbon 4, nitrogen 5, oxygen 6, 7, fluorine, and 8th element sodium. So lithium and sodium identical in properties. That is law of octaves obeys. Or otherwise, suppose let me start beryllium. Beryllium let me start it as 1, boron 2, carbon 3, nitrogen 4, oxygen 5, fluorine 6, sodium 7, and magnesium 8. So beryllium and magnesium identical in properties, in some properties. So again, law of octaves obeys. The same way, I can explain boron and aluminum also. If the start boron is 1, carbon 2, nitrogen 3, oxygen 4, fluorine 5, sodium 6, magnesium 7, aluminum 8. Again, boron is 1, 8th element aluminum, 8th is aluminum. So boron and aluminum are identical in a number of cases. So this is the strength of law of octaves. So only known elements at this time, that is, he proposed this law of octaves. Historical importance. Next, what he was saying is Lothar Meyer, and he has given, again he arranged elements in a different way. That is, it's called the Lothar Meyer arrangement proposed in 1869. According to him, according to Lothar Meyer, so he plotted atomic weights versus atomic volume. This is the most important. He plotted a graph, atomic weight versus atomic volume. From the curves obtained showed the maxima and minima. He pointed out that the elements occupying similar position in the curves possess similar property. So by comparing the position of the elements, so that is suppose a particular element is occupying always in the maxima. So he says that element will be more or less same in identical property. Suppose some element coming below in identical position, that will be element will be we can group together. So that is the Lothar Meyer's arrangement. The most electropositive element, according to the discovery is the most electropositive elements occupy generally peak in the order of atomic weights. Occupy the peak in the order of atomic weights. So now you can see the Lothar Meyer curve. So here it is given. So the important information here it is. Just see here, except this sodium, potassium, rubidium. They are called alkali metals. So they are always occupying in the top of that is peak. So they are in identical properties. So by comparing these positions, so he given here because that is the group he calls the Lothar Meyer arrangement. The next man, Mendeleev periodic table. In his period, 63 elements are known. So what you are saying is Mendeleev. Let me give now. So the proposed table is called Mendeleev periodic table. Actually, this table was proposed in 1869. Mendeleev. During this period, 63 elements were known. Okay. Now, out of the 63 elements known in this period, based on he again grouped 2 elements, all the 63 elements based on atomic weights. He has given a name for the scheme of classification as periodic law. So kindly follow. This is the word introduced by Mendeleev. Periodic law. What is periodic law? Sometimes they will ask. What is periodic law? It states that the periodic properties of all the elements are the periodic function of their atomic weights. So periodic properties of all the elements are the periodic functions of their atomic weight. This is the most important. Atomic weights. Okay. Now, vertical rows were called groups and horizontal rows were called period. Horizontal rows were called period. So he only introduced the 2 terms. One is group, another is period. So he grouped all the 63 elements based on this group and periods he only introduced. So that periodic law was introduced only by Mendeleev. Okay. The next one, under the Mendeleev periodic table, some more information I want to give. So when he was arranging these 63 elements, so the table consists of 8 vertical columns, that is called groups, and 7 horizontal periods. So 8 groups and 7 periods he was introducing. And each group, that is given as 1 to 7, consists of 2 subgroups, namely A and B, and group 8 consists of 3 sets, each one containing 3 elements. So the Mendeleev periodic table having 63 elements, and he arranged in 7 groups in 8 groups and 7 periods, and each group 1 to 8 of 7 means so 1A, 1B, 2A, 2B, 3A, 3B, like this he arranged. So up to 1 to 7, each group consists of A and B subgroups, and the 8th group actually consists of 3 sets. So these are the important information regarding the Mendeleev periodic table we must know. The most systematic method proposed by Moseley. That is called Moseley periodic table. What you are saying is Moseley. The most important, the Moseley periodic table, most important thing is the Mendeleev. We have discussed already. It is based on atomic mass. Now the entire trend is changed. Moseley is discovered the atomic number. He proposed Moseley periodic table is known as modern periodic table based on atomic number. Kindly follow. He only so far before the discovery of Moseley periodic table, that is modern periodic table, entire group of elements are grouped based on atomic weights. Now the entire thing changed. So mostly after introducing the atomic number, so all the elements are grouped together based on atomic number, which said that the physical and chemical properties of elements are the periodic functions of atomic number. This is the most important information. So Moseley periodic table is the modern periodic table, which is normally that is indicated. So the previous version, that is atomic mass based on the group, is destroyed, that is omitted. So atomic number was introduced. And I have already discussed what is, if you know atomic number, we can identify the proton, we can identify the electron. I have discussed. Okay, let me go for the next. So what you are seeing is modern periodic table proposed by, that is Moseley. Now just see here, I have already pointed, that is, he has already, mentally is already introduced, he is again retaining. So here left side, what I am saying, 1A, just see this is 1B. These groups, vertical groups, horizontal periods. So 1A, 1B. In 1A, hydrogen, lithium, sodium, potassium, rubidium, cesium and francium in 1A. The same way, if you go for 1B, copper, silver, gold and the other one, atomic number 11, Rg. Now, kindly follow now. So this is the first 1A, 1B. The same way, you go for 2A, second group, again two subgroups A and B, beryllium, magnesium, calcium, strontium, barium and radium in second A. When you go for, that is second B, it is second B, zinc, cadmium, mercury and atomic number, another element C and having 112. So this is a very important thing. So 1B, copper, silver, gold and 2B, zinc, cadmium, mercury. This is 2A. Now go for 3A and 3A is nothing but boron, aluminium, gallium, indium, thallium. This is the element present in the third A. And third B, here it is coming here. Scandium, that is the family. Tangent elements here. Then fourth A elements, carbon, silicon, this carbon family. And fourth B, here it is titanium family. The same way, fifth nitrogen family, nitrogen, phosphorus, arsenic, antimony. And again fifth vanadium family. And sixth oxygen family, oxygen, sulfur, selenium, tellurium, this family. So here again sixth is chromium family. That is A, this is B. Now the seventh, fluorine family, fluorine, chlorine, bromine, iodine, aspartate, this family members. And here it is 7, manganese family. So 7. So 7 groups consists of A and B subgroups. Coming for the eighth one, eighth group, it's now actually 3 iron families, that is cobalt and the nickel family. These families are present there. So in this eighth group contains 3 groups of elements, iron, cobalt and nickel groups of elements is present. So this is the modern periodic table introduced by that. The last one actually, here it is given as 0, that is helium, neon, argon, krypton, xenon and radon, the inert gas elements that is. Okay. Now, let me go for the next one. So below it is lanthanide, I will be discussing later. So this is according to modern periodic table. Now, let me go for the long form of periodic table. What is the long form of periodic table that what we are using nowadays? That is introduced by Bohr and later Rang and Werner introduced the long form of periodic table. Long form of periodic table was introduced to simplify and memorize easily all the elements of similar properties. So you can ask question, why we have to memorize the elements? Because competitive questions are asked. What way? One among the following element is not alkali metals. One among the following elements is not alkaline earth metals. One among the following element is not transition metal. Like this question can be asked. And if in that case, we have to, some way or other, we have to memorize all the elements, some sort of group. We have to memorize. So in that, because then only by comparison of periodic properties we can write. So, we have to memorize some sort of some way or other, we have to memorize. I will teach you how to memorize. So in that case, so the long form of periodic table was introduced to simplify and memorize easily all the elements of similar properties. So what are the characteristics of the long form? As usual, atomic number is the base. So it consists of 18 groups and 7 periods. So kindly see the difference. Modern periodic table we are introducing 1 to 7 groups. Again 1 to 7 again consists of A and B. 1A, 1B, 2A, 2B, 3A, 3B, 4A like that. And 8 again 3 subgroups. Whereas here starting from 1 to 18 groups according to long form. And this each one there are 7 periods. This is the most important. So in order to avoid under extension of periodic table, lanthanides and actinides are placed separately below the periodic table. This is the most important information. So kindly follow. So what we are seeing here, it is the long form of periodic table. So this is the periodic table we have to memorize. So kindly all other periodic table it is not necessary because it is only having historical importance. Kindly see starting from that is level 1. Under this I have hydrogen. What are the elements present in the first group? I will read just see here. Hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. That is the first group. So let me just tell one by one that what only the first element I will say correspondingly the group, the family I will say. The second groups, beryllium family. Beryllium, magnesium, calcium, strontium, barium and radium. The third group, scandium family. Fourth group, titanium family. Fifth group, vanadium family. Sixth group, chromium family. Seventh group, manganese family. Eighth group, iron family. Ninth, cobalt family. 10, nickel family. 11, copper. 12, zinc family. And coming for this, after 12, 13, boron family. Boron, aluminium, gallium, indium, thallium. That is the family. And 14, carbon family. Carbon, silicon family. Then coming for the, that is germanium, tin, lead, that is. Coming for the 15th group, it is nitrogen, phosphorus, arsenic, antimony, bismuth. Coming for 16th family, that is the group. Oxygen, sulfur, selenium, tellurium, polonium. And 17th group, fluorine, chlorine, bromine, iodine, astatine. And 18th, helium, neon, argon, krypton, xenon, radon. So these are the totally 18 groups. Here, just I want to give some important information. Kindly listen me. So below it is given already. That is the lanthanides, that is the actinides are given. So the first group and second group, just see here. First group is called alkali metals. Alkali metal. First group is called alkali metals. Under these alkali metals, actually except hydrogen, all other metal. Hydrogen is not a metal. It's a non-metal, it's a gas, we know. But coming for the beryllium from the second group, all are metals. They are called alkali earth metal. Right. So now 30 to 18 groups, we'll call it as non-metals normally. In this case, the metalloids are there. Let me explain now. So I want to give one more information. What are the information is? That is 92 elements are occurring in nature. Out of 118, I already pointed out. Out of 92, we can classify solid, liquid and gases, and also metal, non-metals and metalloids. So this information here I have indicated. Just see the metalloids are here: boron, silicon, arsenic and tellurium, antimony. These are the, actually there is one more is germanium. So totally that is boron 1, silicon 2, germanium 3, arsenic 4, antimony 5 and tellurium 6. So these are 6 metalloids, and the other side among these, the remaining will be called the non-metals. We can have, that is remaining. So metals, non-metals and metalloids are there. The most interesting information here in this, so let me come further. How to memorize this? So according to IIT question papers, IIT syllabus itself is given, students are advised to memorize elements having atomic number 1 to 30. So you have to memorize group wise, first and second group, the same way here, that 13, 14, 15, 16, 17 and 18 up to 30 we have to memorize. What way? And period also, like that is moving this side, hydrogen, helium, and same way lithium to neon and sodium to argon, and coming for potassium to zinc we have to memorize. So let me show you, kindly see me. What way? Just look at me. So I will use my fingers, I will show you how to memorize. So let me take now hydrogen. Hydrogen is atomic number 1. So without indicating the atomic number, I will simply say, that means just see here, hydrogen, I am giving this finger, let's see here, hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. So that means, so 1 indicating, 1 means level 1, n equal to 1, that is hydrogen 1, lithium 2, then sodium 3, potassium 4, rubidium, cesium, francium, indicating nth level. So 1, 2, 3 you can. So another interesting information is, just here I have given there S1 periodic table to indicate, to memorize the electronic configuration at the top. In group 1 I have indicated S1. So all the elements present in the first group will be having electronic configuration of 1s1. So if you memorize the alkali metals, like what way? Hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, all will be having S1 configuration. Hydrogen 1s1, lithium 2s1, sodium 3s1, potassium 4s1, rubidium 5s1, cesium 6s1 and francium 7s1. The same way, come for the second group, beryllium group, alkali earth metal. So these first and second group are called normally S block elements. They are called S block elements. When come over 13 to 18 groups are called P block elements. This is S block. And the remaining these will call it as D block elements. Lanthanide actinides is called, that is F block elements. This is the interesting information. So same way, I can go for beryllium again. So how to memorize? Again you have to memorize alkali. That is beryllium, that is I can start from 2. Beryllium, that is you can say magnesium, calcium, strontium, barium, radium. So I will leave the finger, second finger, because for beryllium 2. Beryllium, again, magnesium, calcium, strontium, barium, radium. So it is indicating automatically, if you memorize this order without any mistake, simply you write the electronic configuration. That is 2. Beryllium is 2s2, magnesium is 3s2, calcium 4s2, and strontium 5s2, barium 6s2, and radium 7s2. They can. So first 2 alkali and alkali earth metal we can memorize. The same way, you go for the other side. This is the most important. That is inert gas elements, or that is the correspondingly rare earth we will call it as. So these inert gas elements, gases, so we have to memorize again. What way? Let me give now again. Helium, neon, argon, krypton, xenon, radon. This is most important. Let me repeat again. Helium, neon, argon, krypton, xenon and radon. 6. So except helium, which is 1s2, All other actually will be having that corresponding p orbital information. So helium, even though it is grouped under the p, it is having only one s2. So in all these, what will happen in the electronic configuration? If you go over there, it is nothing but s2p6 configuration. So automatically end will be s2p6. So except helium only is 1s2, and if you go for neon, 2s2 2p6, argon 3s2 3p6, krypton 4s2 4p6, xenon 5s2 5p6. So, and same way, come over this here. The scandium and zinc, again how to remember, I will teach you how you have to. So the transition elements, potassium, again alkali metals, atomic number is given already, it is 90, calcium is 20. Now, so this you have to remember. So the first transition series, because since it is asked already in IIT syllabus, up to 30 atomic number we have to memorize. So let me teach you how you have to remember the first transition series. Let me repeat again. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. So when I am starting with the scandium, two information I want to give under the first transition series. That is, first one is scandium. When I say, first you remember the atomic number. This is 1 mean 21. Because starting after calcium is 20, this is 21. So let me give a number, you can simply atomic number. Scandium 21, scandium, titanium 22, then vanadium 23, chromium 24, manganese 25, iron 26, cobalt 27, nickel 28, copper 29, zinc 30. So atomic number you can remember. Another interesting information. This is for atomic number you can. Suppose for electronic configuration, what we can do is, now start with again scandium, but you can have it in mind, that is, now you can think of the electronic configuration. Scandium D1, you assume now it is an electronic configuration of 1, D1. So scandium, titanium 2, D2, vanadium D3, chromium D4, manganese D5, iron D6, cobalt D7, nickel D8, copper D9, and zinc D10. So this also you can remember. So if you are able to memorize the order either, that is either top to bottom or left to right, a few elements up to 30, so you can very easily write the electronic configuration because it is given already. First one is first group S1, second is S2. Then starting from D2 here, D1 to S2, so S2 is completely filled. So what is the general electronic configuration is N minus 1D, then NS2. This is the general electronic configuration for transition elements. So scandium is, I can simply write N minus, N means scandium in 3D, so it is N minus 4 level, 4th level, 4 minus 1, 3, so 3D1, that is, I can have it as 3D1 and 4S2. This is the electronic configuration for, that is scandium. So like this I can, if I know the element, I can write it immediately because it is given very clearly. So D1S2 third group, D2, D3, D4, D5. So up to, that is 12, it is we can remember. The same way when you go for the P block elements, we can write the electronic configuration very, very easily. So this is the most important, the interesting information I want to give. Let me summarize now. So what we have to do, suppose the next class we are going to study the periodic properties. Under the periodic properties, any question is asked, so immediately it is your duty, you have to recollect from your memory what is the atomic number, where is the position, we have to identify a simple way. So what we have to do is, the simplest method is, the left side, these group elements you have to write immediately left side, and right side these elements, inert gas element you have to write separately. From these you can predict atomic number. If you predict atomic number, you can predict the positions. If you predict the position, you can write the electronic configuration. So my final advice is, so kindly memorize atomic number of elements in group wise as well as periodic wise, that is period wise, for at least atomic number 30. Only if you do this, we can do a lot of wonders in inorganic as well as organic chemistry. I hope you have enjoyed the periodic table. We will see you in the next class. Thank you.